Here I just wanted to look at two additional examples of problems doing chemical reactions. And both these are things I think you, at this point, should know how to do, so I want you to give them a try before I go over them. So first, let's take this one. What mass of silver chloride will be produced from a solution that is made by mixing 40 milliliters of 0.34 molar calcium chloride and 75 milliliters of 0.2 molar silver nitrate, with the equation provided below? So pause me and give this a try first. Let's see if we get the same answer. Okay. So first it mentions this is an unbalanced chemical equation. Let's make sure we get it balanced first before we try to do anything. So at this one I can see there's two chlorines on the left and one on the right. So I know I'm going to need two silver chlorides to make that balanced. And because that means there are two silvers, I'll also need two silver nitrates. Once I do those two, all the rest of the atoms are balanced. There are two nitrogens on both sides, two chlorines on both sides, two silvers, 6 oxygens, and one calcium. If you can't see that from just looking at it, it's fine to do the thing where I've shown you where you just write down how much you have of each atom. Just make sure the numbers add up. That's step one in solving this problem. Step two now is we've got to figure out what our limiting reactant is. So we need to find out how many moles we have of each of these. So let's start with the calcium chloride, and then we'll also do the silver nitrate after that. So we have 40 milliliters of calcium chloride. Now, to be able to use molarity, we know we've got to get this to liters first. So every 1,000 milliliters is 1 liter of calcium chloride. To be able to use our balanced chemical equations, we need things in moles. So remember, our molarity just means moles per liter. So we can say every liter of this solution contains 0.340 moles of calcium chloride. These first two steps get us so that we are no longer in moles, or no longer in milliliters, we are now in moles. Once you're in moles, that's the unit you need to be in to convert between one type of compound and another. In this problem, we need to convert to AgCl because the problem asks me about how much AgCl we can make. So we can see that 1 mole of calcium chloride can make 2 moles of silver chloride. So let's see how many moles that is. So we've got 40 divided by 1,000 times 0.34 times 2. So the calcium chloride could make 0.0272 moles of silver chloride. So that could be our limiting reactant, but it might not be. I also need to check the silver nitrate. So for the silver nitrate, we've got 75.0 milliliters of silver nitrate. And again, the first step is the same. It's 1,000 milliliters per liter. But now we have a different molarity, so this conversion is going to be different, although it's set up the same way. 1 liter is 0.200 moles of silver nitrate. And then we know that this is a 2-to-2 ratio. 2 moles of silver nitrate makes 2 moles of silver chloride. So we've got 75 divided by 1,000 times 0.2 times 2 divided by 2. This will make 0.0150 moles of silver chloride. This means silver nitrate is the limiting reactant and that it can make a theoretical yield of 0.0150 moles of silver chloride. We have one more step, though, because the problem asks for mass, not moles. So let's finish up. 0.150 moles of silver chloride. We will then need to get the molar mass. So every mole of silver chloride has a mass of, let me calculate this, silver, where are you? There you are. 107, not 104. 107.87. So it has a molar mass of 143.32 grams per mole. And so we multiply that times our 0.015, and we get 2.15 grams of silver chloride. So this is how much silver chloride we could make if we combine these two solutions. So as you can see, we just have to use volume to get to moles. And then at the end, we showed you can go moles to grams. So you just use the conversion that matches the information you have. If you've got a volume and molarity, use molarity. If you've got grams and you know what it is, the substance is, use molar mass. Or if you've got pressures, then you need to use all the PV equals nRT and use the ideal gas law to figure out moles from that. Or if you know the moles, use that to then get it into whatever component you need it to be, whether it be like volume or pressure or whatever. Now, I've got one other example here. This one's a gas one now. Ethylene is mixed with chlorine gas at 5 degrees Celsius to generate hydrochloric acid and vinyl chloride. Here's a chemical equation. Make sure that's balanced. Got 2 chlorines. Oh, the hydrogens. 2 carbons, 4 hydrogens. Yep, that's a balanced chemical equation. I want to know what mass of vinyl chloride could be generated if the initial partial pressures of C2H4 was 0.7 atmospheres and chlorine was a partial pressure of 0.45 atmospheres, and it was in a 3-liter container. So from this, we want to get moles from our PV equals nRT equation. Now we need to get some of these things. We've got to convert our temperature over to a unit that's good for our equation. So we need to add 273.15. So this becomes 278.15 Kelvin. Now, I need to know the moles of each and then convert it over to moles of vinyl chloride. So if you rearrange PV equals nRT, you get N equals PV over RT. So first, I'm going to do it for the C2H4. We'll do that first. Its partial pressure is 0.700 atmospheres. Its volume is 3 liters. R is 0.08206 liters times atmospheres per mole Kelvin. And then our temperature is 278.15 Kelvin. Our Kelvin, liters, and atmospheres cancel. And so let's get how many moles we have of this. 0.7 times 3 divided by 0.08206 divided by 278.15. This is 0.0920 moles of C2H4. And I want it to be moles of vinyl chloride, so I'm going to go ahead and convert the fact that 1 mole of C2H4 is 1 mole of C2H3Cl. And so we also get 0.0920 moles of vinyl chloride. Now, we also need to do the same thing with Cl2 gas. So here again, we just have a different partial pressure. So it's 0.450 atmospheres. We have a volume of 3 liters. We have a constant of 0.08206 liters times atmospheres per mole Kelvin. And then a temperature of 278.15 Kelvin. We can see that the Kelvin, liters, and atmospheres cancel. We're left with moles. When we put all of that in, I'm going to get 0.0591 moles of Cl2. And its conversion factor is 1 mole of Cl2 can make 1 mole of vinyl chloride. And so that gives us 0.0591 moles of vinyl chloride. I'm going to rewrite this to make it clearer. Now, we're almost done. We did see that Cl2 is the limiting reactant, but the problem asks us for what mass. So I've got to finish by converting it to grams. So we've got our moles of vinyl chloride down here. And its molar mass, we know that every 1 mole of this has a mass of 62.5 grams. And if we multiply that by our moles, we get there's 3 sig figs in the problem, so 3 in the final answer, 3.69 grams of our vinyl chloride. This is how many grams we could make. So this is just another example of a practice problem. These are good things to go through if you're having trouble, just to make sure you can do all the unit conversion stuff. You'll notice we get to use PV equals nRT in the problem. We get to check and make sure our equations are balanced. We get to do mole-to-mole ratios and then use a molar mass even at the end. So these are good examples that go through a number of those steps that we've been working on. So really, if you can do these 2 problems I just did, you're in pretty good shape in terms of where we're at in 1211 right now.